Hello, statistics students. Here's a video on comparing two population means. We've seen how to compare two population proportions, and now we'll do it for means. So the types of questions that we like to consider when comparing two population means: one, do people comprehend better when they read on paper rather than on a computer screen? Another type of a question that we like to consider is, do those who identified as male spend less time doing laundry than those who identified as female? And if so, how much less? These questions can be answered in part by comparing the means of the two populations. Although we could construct separate confidence intervals to estimate each mean, we can construct more precise estimates by focusing on the difference between the two means, exactly like we did with population proportions. We looked at the difference of the proportions. When we were looking at population proportions, we learned that when we say that we're looking at the difference between two proportions, we mean that we're going to subtract one proportion from the other. So we'll do the same thing with means. We'll subtract one from the other. For instance, we might subtract the mean amount of time Americans spend watching TV every day from the mean amount of time they spend exercising. From subtraction, we learn that if the result is positive, the first mean is greater than the second. If the result is negative, the first mean is less than the second. If the result is zero, then the means are equal. So to show that, we usually will do mu1 minus mu2. And if that result is positive, then you see that mu1 would have to be greater than mu2 for that to be greater than 0. But if this turns out to be a negative number, then that would mean that mu1 would have to be less than mu2. And if they come out to be equal or 0, then they have to be equal. Now, there's something different about population means. We're going to look at two different types of samples. When comparing two populations, it's important to pay attention to whether the data sampled from the populations are two independent samples or are, in fact, one sample of related pairs, which we call paired samples. With paired or dependent samples, if you know the value that a subject has in one group, then you know something about the other group too. In such a case, you have somewhat less information than you might have if the samples were independent. We begin with some examples to help you see which is which, an independent sample or a dependent sample. Independent versus dependent, or also called paired samples. Usually, dependence occurs when each object or person in your sample is measured twice. Like the first scenario posed, do people comprehend better when they read on paper rather than a computer screen? So we could take a person, we could measure how they read on paper, and then measure how they read on a computer screen. So it's kind of like a before and after, but it's the same person. It's when we test the same person at two different times. So dependence occurs when each object or person in your sample is measured twice, as is common in before and after comparisons, or when the objects are related somehow, twins or siblings or spouses, or when the experimenters have deliberately matched subjects in the group to have similar characteristics. The second scenario posed, do those who identified as male spend less time doing laundry than those who identified as female? If so, how much less? So that's going to be independent samples because we're going to look at those who identify as male differently than those who identify as female. We'll look at them as two separate samples and calculate their means. Mean time doing laundry. And as we will see, we analyze paired data or the dependent samples differently from data that come from independent samples. Paired data are turned into difference scores. So we'll go ahead and find their difference before, and then we'll have one value in each pair. Now we just have a single variable and we can analyze it using one sample mean techniques discussed in previous videos. So the big deal here is we treat the independent and the dependent samples differently when we compare them. And in the next video, I'll cover an example on how to distinguish between independent versus dependent samples. And this concludes the introduction video to comparing two population means.